lesson I, or unit I, we have just been graphing. So now when we solve equations, as you just look at these different equations as we go to solve, which one looks the easiest to solve? X squared equals 9. That means x has to equal, oh, not just 3, but 3 and negative 3, right? Negative 3 squared and positive 3 squared both give us 9. If we are looking at this one, this equation, if we are looking at it, it'd be pretty easy to solve, right? Subtract 1 from both sides. 3x equals 6, and x would equal 2. Pretty easy to solve. The one that's probably not easy to solve is this one. And especially with that 1/5, and when we look at that, and when we look at this equation, the solution that you are actually looking at that we will be able to solve is going to look something like this. X equals negative 1.897 or 36.9897. So as we finish this lesson, not necessarily today we're going to do more the first one. So it says there are 3 different ways to solve a quadratic equation. You are going to learn 5 methods in class in the next week or so. You will need to learn all of them, but on the test you get to pick the method that makes the most sense. So as we are looking at these, it says why learn 5 methods. Some are easier than others, but not all methods work for all quadratics. So the easy method will only work on certain types of equations, and we need to be able to choose the best method for each problem. So we're going to start with the pretty basic ones on that next screen down as you are looking at that. Method 1. The most basic quadratic equation to be solved is by taking the square roots or just looking at them. Any quadratic function that does not have a middle b term, so this is key. When it does not have a middle b term, it's super easy to solve those quadratics. So, to solve an equation, finding values of the variables are our solution. Keeping in mind that this is trying to tell us how many solutions. So when you see an x squared versus the x, the linear, there is only one solution for the linear. When you see an x squared, which all of these have a square, they're trying to tell you that there could be 2 solutions. There could be 1, there could be 0 solution. So when keep in mind, 1 solution, only 1, or no solution, but there could be more than 1 when we are looking at those. So if x squared is equal to 81, what number squared gives us 81? 9 and negative 9. And a lot of times you're going to see it written this way, plus minus 9. X equals plus minus 9. Okay? If I take a look at m squared minus 36, easiest way to solve this is add 36 to both sides, right? M squared is equal to 36, which means m has to be equal to 6 and negative 6. Okay? 2y squared equals negative 32. We got to get y squared by itself first. We're going to divide both sides by 2. We're saying what number squared is going to equal a negative 16? What's 4 squared? 16. No solution. How this one is graphed as a parabola is it would be way above like this. It'd be something like this. Or it'd be going down when you look at graphing that. It never crosses the x-axis. This one, if you thought of that Desmos activity, this one is crossing over here at negative 9 and here at positive 9 when you are looking at that equation. And my equation, my parabola would have either been that U-shape going up or going down, but that it went through these 2 points. Those are going to be called my solutions. They're also called my roots. So if we were solving this one, first thing we want to do is add 75. 3f squared is equal to 75 by adding 75 to both sides. Dividing both sides by 3, I get f squared equals 25, which means I'm going to have 2 solutions. F equals positive and negative 5. Okay? So when you're looking at solving these, this is the easiest way when there is no middle term or no b when you are looking at it. Top of page 11. It says, well, how do you graph related to two variable function is finding the x-intercept. So it says if I graph an equation below and I get a parabola with many points on it, the x-intercepts. Where are our x-intercepts? If we are taking a look, our x-intercepts are on that x-axis, and they are these 2 points, -2, 0, and 2, 0. So those of you that got to those later Desmos on that match your parabola, you got to see that you had to always keep it in this factored form of our equation. So it says if we graph those, the x-intercepts are when the y value equals 0, and I can use this fact to find the related to a one variable equation. So if I am graphing x squared minus 4, I can see my vertex down at 0, -4. I am going to be looking at these two solutions. These are my x-intercepts. If I solve the equation and I replace y with 0, x squared minus 4, if I'm actually solving that, I would have had x squared equals 4, and x is equal to that positive -2, same as we have right here. Okay? So all you're doing when you're solving is replacing the y value with 0. So it says a quadratic equation can have two solutions, one solution or no real number solutions. In Algebra 2, you'll learn about the solutions that are not real. Those are your imaginary numbers. Solutions for quadratic equations are called the roots. So the vocabulary here is kind of important. The roots, the zeros. They are also referred to a lot of times as our x-intercept. So if you see x-intercept, find the roots, find the zeros, find the solution of a quadratic. Those all mean the same thing. So whenever we are looking at it, the key thing is it's when y equals 0. Those are my intercepts, my roots, my zeros, my solution. So the method that is best to use if you have a graph is to just look at the graph. So if we are looking at this one, if I give you a graph, those are my two solutions that I'm going to take a look at. If not, we're going to solve. So as we look at this equation, next page down, x squared minus 1. What do we know the vertex is? Vertex is at 0, -1, right? So 0, -1. And if I plug in 1, what's going to happen? It equals, so I'm really trying to look at, if I would plug in x equals 1, right, in that table, x equals 1, I'm going to get 0. If y equals 1, I'm going to get, if I plug in x equals -1 into this equation, 1 squared minus 1 would equal 0. That's this point. If I plug in x equals -1, I'm also going to get this point. So if we are asked what are our solutions for this one, the solution simply would be, what are our two numbers? -1 and 1. A lot of times you're going to see the solutions, they might be written as ordered pairs, or they might simply be written as x equals plus a -1. So if you're asked for a solution, a lot of times we put x equals that number. If you're asked for the roots, a lot of times you might see the answer written this way, as 1, 0, -1, 0. Usually if we say solution, you're going to tell me x equals. So in this case, we want to take a look. If we plugged in and put 0 for our subtracting 5 from both sides, we get x squared equals 0. Where's my vertex? At 0, 0. What happens when you plug in 1? 1 squared is 1, right? What happens if I plug in 2? I'm going to be up at 4. What happens when I plug in -1? I'm going to get 1. What happens when I plug in -2? I'm going to get 4, right? So if I'm graphing that, what's my only solution? What's my y-intercept as I look at that? Where's the only place that it crosses that if I'm thinking about my x-axis? 0, 0, right? So what is my solution? Only 0. There is only one solution. This one had two solutions. This one has one solution. So you would think that looking at this last one that we are looking at, possibly going to be, how many solutions, what do you think? So if we solve this, and we add 2 to both sides, so we solve for 0, if we are looking at that first part. we're going to think that this is x squared equals 4, right? So if you add 2 to both sides, getting x squared by itself, you get x squared equals 4, which tells us that my vertex is 0, 4.
Oh, yeah.
Okay? Is the parabola going up or down? Up. So when I take a look at this parabola, right, if I'm going to take a look at this one at 0, 4, if I plug in 1, I'm going to end up at 5. If I plug in -1, and I keep looking at that, that means when I take a look at the graph, for this one, the graph should have been y equals x squared. This one is y equals x squared if I'm looking at that. And the solution for this one is going to be no real number solution. So when I am taking a look at my graph, this one should have been, instead of this equation, I think we should have had y equals x squared, and it should be plus 4, not just x squared. It should be x squared plus 4. So that when you look at that, it's never going to cross our x-axis, which is here. This one only crossed at 1 point, this one crossed at 2. Those are my solutions or my roots when I am taking all of them. You have nothing to write with, that pencil's right back there. And it says, choosing reasonable solutions. So an aquarium is designing a new exhibit to showcase tropical fish. The exhibit will include a tank that is rectangular prism. It has a length that is twice the width W. So kind of some key information as we are reading the problem. The length is twice the width. The height is 4 feet, and the volume is 500 feet cubed. We are asked to find the width of the tank to the nearest 10th of a foot. So the first thing that we want to be thinking of is, how do you find volume? So volume is length times width times height. Our length, first off, the volume is what? What'd they tell us? 500. So replace volume, that's feet cubed, right? And it says, if we're looking at our information, the height is 4. So instead of putting the 4 in the back, we're going to put that 4 up in front. That's still our height. Times my length and my width. Well, we definitely know the width is W. What do we know? So the width is W. What do we know the length is? Twice. So if this is my width, my length up here, my L, has to be 2W. Do you agree? No. Twice. Not 2 plus W. It's not 2 more. It's just saying that the length is twice the width. So if I know the width is W, the length is 2W. So I kind of switched the order around here. So I have 4 times 4 was my height, times my width W, times my length 2W. I'm going to rewrite that, and I'm going to put the variable part first, so as we are looking at this. So I'm going to put 4 times 2 gives me 8 W squared, agreed, W times W, equals 500. So this is very much like those problems we were just solving, except it was given to us in a story situation. We're going to divide both sides by 8. And it doesn't come out to a great number, but it's not bad. W squared is equal to, when you do your division, someone have their calculator put it in for us, 62.5. Now, I don't know if you realized before that when we had something like x squared and we said it equals 25, we were actually taking the square root of both sides. So to get rid of our square, we are taking the square root. And on this side, when you take the square root, it's always the plus minus, and then it's that square root of 25. That's how we got positive and negative 5. So in this case, it's W squared equals 62.5. W is going to be equal to the positive and negative. And we are going to take on our calculator 62.5 and take the square root. I see a lot of you don't have calculators, so it takes time. This is great when we are solving a quadratic, but this is a real life problem. Can we have a negative 7.9 length of a side of an aquarium?
Yeah.
No. So what is our width of our aquarium? 7.9 feet. You are not going to have the negative, right? Solving the quadratic gave us the 2 solutions, positive and negative 7.9. But in the story situation, the width is 7.9. Could we have found our length also? What do I have to do to that? 2 times that width, 7.9. That, they didn't ask us to find that, but you could have found that, right? So, that next part down in your notes is what we want to be taking a look at next. So it asks us some questions. I'm going to show you their answers. I know they're a little long in the writing part, but it's probably neater than my writing it out and you trying to copy down what I wrote. So, the first question, why did we not include the negative in our previous answer? And you don't have to have as much as I have here, but key reason it can't be negative is if we are looking at that, our domain and range, right? They're not possible. We can't have a negative measure. So pretty much you just got to say something about negative numbers are not possible when we're looking at measurements, right? Negatives can't be measurements. How many solutions are possible to each quadratic equation? And we're talking about in general are 3 different ones. We could have 0 solution, right? It didn't ever cross the graph. We could have 1 solution where it's right on the x-axis, or if we are looking at it, we can have 2 solutions for when it crossed at those 2 different points as you were looking at those. The third thing that we are looking at, how many solutions are possible for quadratic equations. And again, we want to think about solving or the roots. So how many solutions for any quadratic and how many possible solutions. That kind of goes hand in hand, those two. There's either going to be 0, there's going to be 1, or there's going to be 2 as we are looking at those. So the 0 solution, you can't take the square root of a negative number. So 0 solutions, if we are looking at that, is going to be when we cannot find, get x squared equals negative 36. Square root of a negative is not possible. We're going to have 1 solution if it's only 0 or 1, which are quite a few of those when we think of how those are written. And then 2 solutions is when you have the 2 possible roots. So the 0 solution, again, as you are looking at that, that's when you graph it and you have x squared equals negative 25. No solution. 1 solution, x squared is equal to, and a lot of times it might be 0 or it could be another number when you are solving. And then the 2 solutions is when you have x squared equals 25, because you will have both a positive and negative. Here you're talking about the 2 points as your graph. That's your 2 x-intercepts. The 1 x-intercept could be just like this, where it's just this 1 point, or no solution is when it's either going to be totally above or totally below that parabola. And it never intersects the x-axis. So you just kind of got to watch for those